Today we're going to look at column families and why you might want to use them in CockroachDB. If you go down low enough, CockroachDB becomes a key value store, and when you make an update to that key value store, the whole row is updated. Meaning if you're only updating a single column and that update happens frequently, you might be doing more work than necessary in order to make that update. So essentially what column families do is they split the underlying key value store data into multiple entries. The table identifier will be at the start. Then we'll have our columns, so ID, its value, the name, its value, and any large columns as well. So for example, the user's avatar or image and its value. Instead, column families will allow us to split that into multiple entries. The table identifier will still be at the start, along with any column family identifier, and then we'll have our ID in here and name, but then we'll have a separate column family for anything else, our image and its value, and anything that's not included in the first column family. That way, changes to, let's say, the name will result in this entry being updated, but not this one. Whereas previously, a change to the name would have resulted in everything in this entry, including any large values that we might want to leave untouched, being updated as well. By splitting columns into separate column families, you'll also reduce contention when making those updates. Let's create some column families now and see what kind of benefits they can give us. First, I'll create a cluster. Then I'll create two tables, a member table with an ID, full name, an image representing a user's avatar, a public key, and two metadata columns. These will be synthetically large for the demo. I'll create another table, member_f for family, with the same columns, but this time split into two column families. One representing the basic columns, the user's ID and full name, and another called large. These could be called anything, containing the user's image, public key, and metadata columns. With that done, I'll insert some test data. And with the data inserted, I'll run a load test against both the tables. First, we'll run 1,000 reads against the table and report the average latency. Second, we'll perform 1,000 updates to both tables and report the latencies again. So here we have the average time it took to run 1,000 reads against the member and column family version of the table. I wouldn't expect selects to be vastly faster, but updates will have a performance boost against the non-column family counterpart. We're reliably seeing that updates against the column family version of the table takes about 80 to 90% of the time that the non-column family counterpart takes. Let me show you what's actually happening under the covers when column families are employed. In this query, I update the non-column family table, setting the full name to be an arbitrary value, where the ID is, again, another arbitrary ID. The values aren't important. What we see is, in this update, all of the columns are being updated. Whereas, if I run the same query against the column family version of the table, only columns that we're using and the new value for the column are being used. There's less work for CockroachDB to do. Another interesting area of column families is change feeds. You can choose to omit only the columns captured in a given family or families within a change feed. You can also split CDC messages by column families. Let's do that now. First, I'll attempt to create a regular change feed against a table with column families. CockroachDB won't allow this, and it will suggest an alternative. Because this has multiple column families, it's suggesting that we use the with split column families to omit all of the columns of an affected row. Taking that into consideration, I've added the with split column families. I don't want any initial data. And this time it's created it. It's saying that member F has two underlying column families and messages will be emitted separately for each of those column families. I'll create another change feed against the same table, but this time I'll only want to capture the columns in the basics column family. Note here that I haven't had to provide the split column families because I've provided the column family that I'm interested in. I'll create that and then I'll listen on both of those topics. One for the basics and one for the split. If I insert data into that table now, we'll see that I got data for both of the column families, the basics, the ID and full name, and the large column family, the image, the public key, and the metadata columns. For the basics, I captured just the ID and the full name, the columns in the basics family. If your table has many families and you're interested in a couple of them, use this syntax for table and family pattern separated by commas. So for example, this change feed will omit columns in the basics and large families whenever anything changes in one of those rows. Our customers tend to use column families when they're making lots of updates to small columns and they don't want the rest of the columns, perhaps larger columns, to be rewritten on every update. If your mutation queries are taking longer than you'd expect, try splitting frequently written to columns into their own family to limit the scope of those updates. And if you don't need all of your columns in a table being emitted via CDC, column families also come into their own for change feeds.